This lesson is going to go over the use of the distributive property. The distributive property says that for all numbers a, b, and c, so in this case we're saying a, b, and c are just different random numbers. They can be positive, negative, decimals, fractions, whatever number they might be. If you have a multiplied by b plus c, so there's two numbers added in parentheses and then multiplied by a. You can distribute this a to the b and to the c. So what you do is you write what's in parentheses, b plus c, and then you multiply that a by both of those numbers. Now in this case, we have b minus c in parentheses. So you're going to write b minus c, and then you will go ahead and distribute that a to both the b and the c. It really does help to just show examples. So we're going to show how we're going to use the distributive property here. Now, what most of you are saying and thinking is that why wouldn't we just add 3 plus 4 and take 5 plus 7? Well, according to the order of operations, we would do just that. We would take what's in parentheses first and then multiply it out. However, we are learning how to use the distributive property here, so I want to show you an example how we could distribute that 5. Okay, so we're going to distribute our 5 to our 3 and our 4. So what you do is you write whatever is in parentheses. So we're going to write 3 plus 4, and you kind of stretch it out a little bit. And then the 5, it's kind of like a visitor. It's going to go visit everyone inside of the parentheses. So you're going to multiply both of them by 5. So now you have 15 plus 20. And that gives us 35. Now, this is just an example. If you had this problem, you would use the order of operations. Either way, you end up with the same answer. But this is just to show you how we're using the distributive property. We're going to end up having an x in here or some other variable inside the parentheses. And you're going to have to know how to use the distributive property. All right, here we have another example, and you would go ahead and use the order of operations if you were solving this problem normally. But in this case, we want to use the distributive property to show how to solve this problem. So we're going to write what's in parentheses. We're going to have our 2 minus 5, and then we're going to have our 9 visit the 2 and the 5. If this is subtraction in here, you have to keep it subtraction. So we're going to multiply the 9 by both numbers inside of the parentheses. And again, you got to keep that same operational sign. So we have 18 minus 45. Go ahead and put that into your calculator. 18 minus 45, and you get negative 27. Now, you could also say 18 plus negative 45 if you prefer to add the numbers that way. That's perfectly fine as well. Now, if you were using order of operations, you would have 9 times 2 minus 5 is negative 3. You'd get your negative 27 right away. But again, I'm teaching you how to use the distributive property. Okay, now I'm going to use the distributive property again here, only this time I do have a variable in the problem. So there is no using the order of operations to take a shortcut here. I'm going to use the same process. I'm going to have the negative 4 visit the x and the 6 in the problem. So I'm going to have negative 4 times x minus negative 4 times 6. Now another way that I have students think about this, remember I said write what's in parentheses and stretch it out. So we have x minus 6, and now I'm going to let the negative 4 visit both of them. And so that's another way that you can write that out. So you'd have negative 4x minus negative 24. Now you could change this into plus positive 24. So you'd have negative 4x plus 24. In this problem, the 5 is on the other side of the parentheses, and I purposely did this in this problem so that you would know when you get to these problems in the book that it's not confusing. You can put that 5 right outside in front of the parentheses if you wish. It's the same thing. It's the associative property of multiplication. You can take x minus 1 times 5 or 5 times x minus 1. You can rearrange them. So now we want to distribute the 5 to the x and the 1. So you're going to write what's in parentheses and stretch it out. You're going to let the 5 visit each number inside of the parentheses. So 5x minus 5 times 1. So now we have 5x minus 5. Now in this case, we have it all distributed already, and we got to go backwards. So this is, the directions are rewrite the expression using grouping symbols. So we want to go back to the way it was. Now think about what number was outside. The number that gets to visit each number goes outside. So we're going to have a 7 out here. And then if we take these common 7s away, common factors, then we're left with 5 plus negative 6. And there we go. We rewrote the expression using our grouping symbols. Now, if we went backwards and we did use the distributive property, we would have the 7 visit the 5 and the 7 visit the negative 6. So we would have 7 times 5 plus 7 times negative 6. And that's what we started with at the beginning. So in this type of problem, we're going backwards. So if you're asked to rewrite the expression using grouping symbols, you're going backwards. You want to find the common factor. What do these two things have in common? They have a 3 in common. So let's take out the 3 and put that in front. And what are we left with? We're left with x plus 7. X plus 7. Now you can check this by using the distributive property. We can distribute that 3, x plus 7, 3x plus 3 times 7, and that's what we started with. So our answer here is correct. Okay, the first thing you want to do is look for that common factor. We have a 5 in common, so we're going to put that 5 out front. Going to get rid of the 5s here. What are we left with? 8 minus x. 8 minus x. And we can check that by distributing that 5. 5 times 8 minus 5 times x. And that's what we started with. So our answer here is correct. Now this one has 2 variables in it, and don't let that mess you up because it's the same exact process. We want to look for any 2 factors that we have in common. They have a 6 in common, so let's go ahead and put the 6 out front. Cross those out. What are we left with? N minus D. And that's our final answer. Now in this problem here, we have a lot of 5s, but we want to know between these 2 expressions here, what do they have in common? Well, they have 1 5 in common, so we're going to put 1 5 out front. We're going to get rid of 1 5 from each one of those expressions, and we're left with 5 plus negative 4. Using the distributive property for mental math is very useful when you don't have a calculator around. So you can expand 65 to say 2 times 60 plus 5. And so instead of doing 2 times 65 in your head, you're going to do 2 times 60. Here we've distributed this, plus 2 times 5. 2 times 60 is 120. 2 times 5 is 10. So you just add that up. I know that this seems like a longer process, but it actually does work. So instead of doing this math in your head, break it up into 60 plus 5 and distribute that 2 to the 60 and the 5, and then continue to add. Here's another example of how we can use the distributive property for mental math. 8 times 102, instead of doing this problem in your head, you could stretch this out and say 8 times 100 plus 2. So now you can distribute the 8 to the 100 and the 8 to the 2. So we've distributed the 8 to the 100 and to the 2. Now we have 800 plus 16. We have 816. So try this. Try to use the distributive property like this to solve your mental math problems to see if it does make it easier for you. Okay, I want you to think about how you would use mental math to solve this problem. Pause the video and use the distributive property, see what you come up with, and then go ahead and turn it back on. What I would do, I would break this into 5, well, I'm going to do it down here, 5 times 90 plus 8. And then I would distribute the 5 to the 90 plus the 5 to the 8. And so I would have 450 plus 40. And now I have 490. So instead of me trying to figure this out in my head, 98 times 5, this would be 0. Bring a 4 up here, 490. Like, to do this in my head, it's a lot harder for me to keep track of all these numbers than it would be to use the distributive property to break it up. And I can do this in my head a lot easier. So this is the process that you can use when you don't have a calculator. Now, if you do have a calculator, you just punch this right into your calculator and you get your answer. But if you need to do the math in your head, maybe you're at the store and you need to figure out the cost of something, use this method here. Use what you know about the distributive property to determine the value of the variable. So what we're going to do here, we're going to look at how this was solved, and we want to figure out what is A equal to. Now let's go ahead and put them into the same format. We're either going to distribute this 5 out, or we're going to rewrite this with a grouping symbol. Let's do that method first. Let's figure out what this would look like with a grouping symbol. They have a common factor of a 5. So I'm going to take the 5 out, and what do I have left? I have A minus 7. A minus 7 is equal to 5 times -1 minus 7. So if you look at this problem, you don't have to solve it. It looks like it's going to be a really tough equation to solve, but really it's not. What should go in this place here? A -1. So A is equal to -1. Everything else about the problem is all there. Everything else is the same. The A is in place of the -1. So when you get to these problems, don't think that they're really tough equations to solve. You can do it. You just have to put the two sides in the same format. Okay, now this time I'm still going to put them in the same format, except this time I'm going to distribute the -2 over here so we can figure out what x is equal to. So I'm going to have -2 times 4 plus -2 times 1 is equal to, I'm going to distribute this out, x plus 1. I'm going to distribute the -2 to both places. Now, what does x have to equal? If you look at the other side, what's in x's place here? A 4. So that means x is equal to 4.